Right, hi everybody, welcome back. This is the second video in section 7.2, causes and impacts of climate change. In this one I'll cover the impacts. If you haven't watched the previous video where I covered causes, please watch that first. Obviously, it's going to be difficult for me to cover in a short video one of the biggest existential crises to hit humankind in human history, but I'll do my best. So what I've done is I've tried to split up the impacts into two main categories. One I've called environmental effects, as you can see above my head, and the second I've called societal effects, or effects on human societies. Interestingly, I think I could have chosen to do a third category, which I would have called economic effects, because as you know, that would complete the three pillars of environmentalism. But the syllabus doesn't really push us in the direction of economic effects. However, if I was going to talk about economics, I think that the big impact is not necessarily what climate change will do to the economy. It's how humans would have to change the economy to deal with or try to prevent climate change. So, the best way to avoid climate change would be to move from the current linear oil-based or fossil fuel-based economy towards a circular economy based on renewable energy. Okay, so let me quickly go through the syllabus. I think I prefer the way that I've set out my two categories than the way the syllabus lists all of these things here, but I'll read through it anyway. So the syllabus says the potential impacts of climate change may vary from one location to another, and they may be perceived as either adverse or beneficial. These impacts may include changes in water availability, distribution of biomes and crop growing areas, loss of biodiversity and ecosystem services, coastal inundation or flooding, ocean acidification, and damage to human health. So as I say, I think I've set it out a little better with my two categories. And then the syllabus says we also need to cover both negative and positive feedback mechanisms associated with climate change. You're possibly already familiar with a few positive feedback mechanisms. So these are things, or often referred to as tipping points, the point where positive feedback will take over due to climate change, and we reach this point where it's irreversible. Interestingly, the Paris Climate Agreement was based on the idea of trying to keep global temperatures below a 2 degrees Celsius rise in the 21st century, or 2 degrees above pre-industrialized levels, because that 2-degree rise, if exceeded, was seen as reaching the main tipping point where positive feedback would take over and be irreversible. And then under applications and skills, the syllabus just says we need to discuss these main feedback mechanisms. Okay, so let me move on fairly rapidly. This is basically the same information that's above my head. I've added a few more things that we can think about for each one. I'll try to go through them fairly rapidly, point by point. So first of all, let's cover these four main environmental effects. So first of all, under weather patterns, well, you already know what weather is, and you already know that weather is driven by solar radiation, as are circulation of water and atmospheric currents. On one level, we can expect, and we're already seeing, retreat and melting of polar ice caps and glaciers. And we're also perceiving these increases in extreme weather events. So that means not necessarily that we're going to see more hurricanes, more flooding events, but more extreme examples of those things happening. And that seems to have been happening over the last few years. Certainly, opponents in the debate of climate change, which we'll cover later, would point to the fact that it's very difficult for scientists to actually link cause and effect. And that's true to a certain level. I'm in Mexico City, and certainly I've been here for 13 years, and in the last 2 or 3, although it is only anecdotal evidence, it seems to me that the dry season is being much drier and lasting much longer, and the wet season appears to be much wetter in Mexico City. As I say, though, only anecdotal evidence. In terms of global coastlines. As ice caps melt, North and South Pole, we expect, and we're already seeing actually, sea levels to start rising. That's very bad news for coastal cities, but especially bad news for coastal cities in LEDCs and low-lying areas, for example, Bangladesh, because they're much less likely to have access to money and technocentric um, solutions to try to hold back water. Then in terms of ecosystems, well, the main thing here is the idea of biome shift or changes in biome distribution. Now, you know that biomes or the boundaries of biomes are based on certain physical factors, and one of the most important is temperature. If we change temperatures in different parts of the world, then species won't be able to survive there anymore. So therefore, will be expected to migrate to areas where they can survive. So that means movement of animals and plants horizontally or across latitudes, but it also means changes in the distribution of animals and plants vertically in terms of altitude. Now, another example of that seems to be happening at the moment is in Africa. So traditionally, African settlements in ancient times were built above the mosquito line. So not at low altitudes, because then the mosquitoes would be prevalent and obviously spread diseases like malaria. So it made sense to build settlements above the mosquito line. And that mosquito line appears to be getting higher in altitude these days, and people that didn't previously live with mosquitoes and with the spread of malaria are now finding that they're living basically within the mosquito line. Okay, in terms of society, I've split it into another 4 categories. Water resources. Well, I've already mentioned that we might expect changes in weather patterns because these weather patterns are driven by atmospheric and ocean currents. If that happens, places might become drier, especially places already under water stress, and wet areas might become even wetter. So areas that depend on monsoons might see those monsoon seasons changing. What's going to say about that? Agriculture. Well, in terms of agriculture, similar changes to biome shifts. Traditionally in the US, the breadbasket states in the south and centre of the United States might not be at the correct temperature to be able to grow specific crops. So in future, governments might be forced to move crop growing areas to more northern states. In terms of coastal settlements, well, I've already mentioned changes in water levels might lead to technocentric approaches. It might lead to mass emigration away from places that are affected or cities that are affected by rising sea levels and increased storm events. And then finally, for human health, well, certainly as places get hotter, and this year in Death Valley, California, the hottest temperature ever recorded in human temperature is recorded. We might expect increased levels of heat stroke, increased mortality of old people in summer seasons that are getting very, very hot. In MEDCs, it might be tackled by having a much greater reliance on air conditioning. But obviously, again, in poorer countries and LEDCs, that's often not an option. So, as usual, the parts of the world or the countries that were not responsible for these changes are likely to be, these LEDCs, likely to be the countries that suffer the most. Okay, maybe one thing I forgot. If we talk about the water cycle, I mentioned that the water cycle is driven by these ocean currents. As surfaces get warmer, currents move across the surface of the oceans, and as the water cools, it sinks and causes these currents to repeat. If salinity changes due to melting ice, land ice at the poles, we might expect that to have an effect on circulation. If there was a huge loss of ice at the North Pole, it's speculated, or around Canada, maybe in the Arctic, it's speculated that it could do something very drastic and have very long-lasting and drastic effects on the Gulf Stream. If that happened, Europe will become much, much colder, and we could end up with Europe heading towards a man-made ice age. Okay, let's move on and let's talk about feedback mechanisms. So 2 slides. I've made one on positive feedback mechanisms, as you can see here, and the second one on negative. Fairly squashed together, so I could put it all onto one slide. But I came up with 5 possible positive feedback mechanisms. Some of them you'll be aware of already. So one of the most obvious and one of the most talked about is the albedo effect. So the albedo effect of the Earth is relying on the scientific observation that white surfaces reflect more energy. So therefore, white surfaces at the poles are responsible for reflecting a lot of solar radiation back into space. If we lose those white surfaces, we lose the albedo of the Earth, or the albedo decreases, and therefore we have this positive feedback mechanism where melting ice increases temperature and causes more melting ice. Effectively, it's a runaway tipping point. Okay, number 2, I know we've mentioned this in our class before. There's speculation, or there's actually evidence that it's happening, as permafrost melts in the Arctic Circle in areas like Siberia, methane is released from underground. This methane originates from rotting vegetation from many years ago that was trapped under the permafrost and therefore couldn't escape, and now is being released in high quantities back into the atmosphere. So that's a second possible positive feedback mechanism. Number 3, less obvious maybe, but there is speculation that increased temperature will cause bacteria, or decomposing bacteria, to work more efficiently and therefore release more carbon dioxide into the atmosphere due to this increased rate of decomposition. Number 4, as the rate of deforestation increases, as obviously you're aware of, we have more and more effects on the climate. Less and less carbon sinks, and therefore increasing carbon dioxide and increased changes in climate. And then finally, number 5, because of biome shifts, we might expect trees and plants to grow in areas where there was previously white surfaces of ice, snow, and permafrost. If that happens, the albedo would be expected to decrease even more, and again we have this runaway positive feedback effect. Okay, so 5 possible positive feedback mechanisms. Negative feedback mechanisms, possibly less obvious and possibly a bit more speculative, I think. But so it has been suggested that increased evaporation around the equator could lead to more moisture going into the atmosphere in the tropics, and therefore leading to increased snowfall at the poles. So therefore we might expect the albedo to increase, the opposite of what we talked about with positive feedback. And then secondly, a second possibility, increased levels of carbon dioxide might lead to increased levels of photosynthesis, especially in rainforests, so therefore might take carbon dioxide out of the atmosphere. However, quite speculative, these things. Okay, so I went through that very rapidly, I'm afraid. Probably quite a few things I forgot to talk about. Certainly we'll go through this in more detail in the classroom. I hope that was helpful, and I'll speak to everybody soon. Okay, goodbye.